a product that's a visualization, plotting API, and it's also on the cloud and also on premise, so you can create plots on the site, or you can use R, Python, MATLAB, or other things to create plots and push them to Plotly. And they're going to talk about that. And Chris is responsible for engineering and other things. So please welcome Plotly.
Thanks. So thanks so much, everyone, for coming out. I'm Chris. I work on Plotly, and I've been working on it for about the last year and a half now. It's really good to be in LA. I came down from Montreal, and this is what Montreal's looking like right now. So I love the blue skies. I love the warm weather. It's good to be here. What's that?
Not today.
It's better than ice. So we've been working on Plotly for about a year and a half now. And a year and a half ago, we started seeing a lot of really cool things happen in the web for visualization. Things like D3.js and all these incredible graphs that you could create in SVG in the browser if you were a JavaScript programmer. And we started seeing things come out from our friends at the Google teams who were playing around with WebGL and creating these awesome interactive graphics in the web. And we really wanted this. But myself, I studied math and I studied electrical engineering, and I wasn't really a front-end developer. A few years ago, I thought Java was the same thing as JavaScript. And I was working in MATLAB running simulations. And I was working with people who were working in Excel. And so to create these types of visualizations that we were seeing in the web, it was just totally impossible for us. This is 2010, New York Times data visualization team. It was probably like a team of 7 people that created this graph, and it's awesome. I wanted to be able to create graphs like this in the web browser, even if I wasn't a pro at JavaScript, even if I thought JavaScript was the same thing as Java. And so that's why we started Plotly. We wanted a platform that made it easy to make beautiful visualizations in the web. Even if you weren't a programmer, or if you were and you are using things like MATLAB or R or Python. So here's the same graph, but recreated in Plotly. I made this just by uploading an Excel spreadsheet to Plotly with the data from that graph. It's saved to my online Plotly account. It's interactive. I can zoom in. I can pan around. And it's built on top of D3.js, but you didn't necessarily need to know that to create this graph. And here's this graph that I created in Plotly, and when I share it, I share not only the graph, but also the underlying data that makes up this visualization. And this is this interactive graph that I created in Plotly. It's really great for sharing. I can embed it in a web page, or if I want to put it into a report, and I want a static version of it, I can add .png to the URL. I can generate a static version of this. Since we started creating Plotly a year and a half ago, we've seen almost over now 100,000 people come to Plotly to make and share their graphs. And these are people from all different types of industries, all ages. Things like contour plots, bar charts, journalists coming to make and share their graphs, scientists, engineers, people in BI. And we've learned a lot in the process about this. First, that graphs are kind of hard. There's a lot of little things that different data designers need in their visualization packages. Things like custom hover text, being able to zoom and create bubble charts. Things like contour plots, which we used a lot in previous jobs as physicists. Things like multiple axes, where if you pan on this axis, the top two subplots move. You can zoom in, move around. Things like insets. Subplots that have linked axes, so if you zoom into this region, the other two histograms will also zoom in. These were all graphs that we were creating in our sort of prior lives as engineers and physicists, but we were creating them on the desktop and creating them in tools that were costing several $1,000s and that only one of us at our company could afford to use. And now you can create and share these graphs online for free with Plotly. Things like multiple axes, fits, journalists who are checking out Plotly. And we just started playing around with WebGL and 3D graphs in the browser. So this is what we've been up to for the last year and a half. And now we're seeing a lot of people check out the Plotly platform for their work, and it's really exciting to see all these graphs created and shared on a common platform, and created and shared by people who might think that Java is the same thing as JavaScript. And people creating graphs that are updating in real time in the browser. So how do you get started with Plotly? We've written libraries that interact with the platform in R, in Python, in MATLAB that will render these graphs in the browser for you. So I'm sure there's a lot of R users here who already are using a great graphing library like ggplot. One of the things that we're working on is a way to convert ggplot graphs into online interactive Plotly graphs. So if you load up our library and you create a ggplot graph that looks something like this, it's a static version inside RStudio, and you get to the point where you want to share it, you can install our package and call this command ggplotly, which will take all of the style behind this graph and all of the underlying data behind this graph, and it'll send it up to your Plotly account, and it'll redraw this graph using our graphing library built on top of d3.js and make this interactive version of this graph where you can zoom in, pan around, and you can pretty easily share. So you can continue to use the really incredible syntax of ggplot and that incredible philosophy around designing figures. And we've kind of just built a different way to draw them, a different drawing engine on top of ggplot. This same interface for ggplot and converting those figures into Plotly ones that are drawn with JavaScript, we've also done for MATLAB, and we're working on it for Matplotlib in Python. So if you're working in MATLAB, creating surface plots or logarithmic graphs, you can call fig to Plotly, which will do the same thing. It'll take all the data behind this graph, it'll take all the style information behind this graph, and it'll send that data and that graph up to your Plotly account. It'll redraw it with our own defaults, and then here's this new version of this graph that you can share and interact with. And the same thing for Matplotlib. So here I am in IPython notebooks, and I created this graph with Matplotlib, and here it is rendered. And pushing this to the web and redrawing it with web-ready graphics like SVG, we just call this command in our Python library iplot_mpl, which will take all this data and all the style behind it and redraw it in Plotly, sort of an interactive version of it that's hosted on the web. And we're also going into sort of other programming languages. Things like people are starting to use Julia for doing some data analysis and in redrawing these graphs with the Julia language. So the really cool thing about doing web graphics and making a web graphing library is that in each of these programming languages, you can convert native objects, like in Python or in R or in MATLAB, to a universal object, JSON, and then send those up to the Plotly server, and then we just read JSON, and then we just draw it with JavaScript. So in this way, you can we've been able to create a unified graphing library across all of these different languages just by turning native objects in these different languages to JSON, bringing that into Plotly, and then redrawing it with our graphing library. So those are the different kind of ways that you can create Plotly charts with different programming languages. And we've also been working on just a simple spreadsheet in the web browser, entering data or uploading data like from Excel spreadsheets or CSV files, bringing it in, making the different types of charts, in this case like a scatter plot, and coming in here and editing things about the graphs, just editing the different SVG elements, things like the colors or the symbols or the different axes lines. In this case, we can just remove the lines or add grid lines, make the ticks a little bit bigger or the points a little bit larger. And once we're happy with it, save it, and then share it just with the URL. So this, at a high level, is what we're working on. Just a graphing library that's built on top of D3.js and the great stuff that's happening in the WebGL world, making it accessible to people who are working in different programming languages like R and Python and MATLAB, or just using a simple spreadsheet. Adding the ability to update these graphs in real time in the web browser. And bringing the same sort of sharing functionality that we're really used to with other platforms that we're using, like Instagram, and bringing that to technical computing so that you can share your graphs and your data sets just like you share your photos to your friends or your colleagues. We want to bring all these types of tools to the web. This is where we are right now with Plotly. And since we've started working on this, we've seen a lot of use of Plotly from industries that we weren't initially familiar with before Plotly. So things like business intelligence. And we're starting to see that people are starting to want to use sort of real backends to do their data analysis at industries. So instead of dragging and dropping visualizations or doing things like in Excel, they're starting to use the awesome programming packages for data analysis like pandas in Python, or people are starting to use, switch from big kind of monolithic BI tools over to R. And doing data analysis with code instead. And that's becoming so much more accessible right now with things like Coursera courses that are teaching data analysis. And we're starting to work with those tools in R and in pandas and make it really easy for people to build really rich visualizations and interactions in the web browser that have these tools in the back end. So this is one of my favorite examples. This is in IPython notebooks, and I loaded up about I think 300 megabytes of these 311 calls in New York City. So 311 calls are like if there's a tree that has fallen down on a sidewalk. They call 311 and report a complaint. So here's this table of these different 311 calls. It's got several dimensions of data. It's over several months. It's about half a gigabyte of data. And so I loaded up this data with pandas inside Python, printed it out in this IPython notebook, and then made with a little bit of custom JavaScript and a little bit of HTML, a filter that, little controls, little web-based controls that filter through this data. So here's a graph of the most common complaints of this data set. And if I want, I can filter these by different complaint types. So if I start typing in tree, or if I type in things like agency name and type in NYPD, I can see the most common complaints to the NYPD. And what is happening on the technology side of things is, as I type in these different complaints in JavaScript, I'm taking these events and then I'm sending it to a Pandas backend that's filtering this data and then sending it back up to Plotly entirely in the client without communicating to any servers and redrawing these graphs. And so this is kind of where we see data analysis and interactive visualization going, is using great backends like Python and Pandas or R to do the analysis and the heavy lifting, and built around those types of open source packages, and then interactive web-based visualizations on the front end to display those graphs and to share that data. So that was a lot and probably really quick, but that's basically all I wanted sort of to share on what we were working on. Are there any questions?
So could somebody use Plotly to build a data product and use Plotly as the visualization engine for it, and then put an authentication layer on there to make sure that only their clients could access it?
Yeah, exactly. So the way it works for that is I showed you all these graphs that are saved on Plotly's public cloud. And we have sort of a really similar model to GitHub, where you can make graphs and data publicly for free. And you can make like up to 10 private graphs for free on Plotly's public server. But this same server technology you can install on your own enterprise. So we kind of have this enterprise version of Plotly that can be installed on private servers behind a firewall.
This is a real businessy question. Is your licensing per user licensing?
It is.
Okay.
Yep.
So infinite number of clients, doesn't matter if it's per developer or per active reader?
It's per developer. Yeah. And then for large applications, like if there's several thousand or government applications, it's a slightly different model, and we work with people on a one-to-one basis on how that scales. Yeah.
Can you repeat the question when they ask you to?
Oh, sure. Yeah.
Do you have a trial version for server installation?
Yeah, we do. That's usually how we start with people too, since it's kind of new technology. It's just like a 30 to 60 day trial of Plotly, and we help people work through it.
CPU, how you license servers?
We license by user.
By user.
Yeah.
Get any information from the web? Do you do any crawling as well? To get the information from the web on what to do the analysis?
Sorry, say that again?
I mean, when to get the information from the web.
Yeah.
Some crawling, to get the data and then do the analysis.
Oh, I see. So the question was to get the data up to the web, does Plotly do any analysis? And we don't. We just sort of exist as a visualization layer. So what people will do is they'll use things like Beautiful Soup or something in Python and grab their own data and get it into a form and then send that up to Plotly. Same sort of thing with people who might be integrating several different analytic backends to Plotly, where they're pulling data from Salesforce or from Google Analytics or crawling from the web, but using tools like Python or R or MATLAB to do that, and then combining those data sources and then sending it up to Plotly and building interactive visualizations with Plotly around that. Mm-hmm.
What's the top 311 complaints? The Knicks and Al Sharpton?
It's actually hot water. Yeah. Yeah.
So a technical question about your implementation. I want to make sure I understand what you're doing.
Yeah.
So if I build a graph in ggplot, don't print it, right? I just get back the graph object.
Yeah.
Are you literally just walking down the object tree, serializing JSON to a common format, and then putting that and using that to drive the visualization?
Exactly. Yeah.
And you built a common engine. So you built a superset of all of the graphing terminology that you think you're going to need.
Yeah, exactly. And it's been kind of fun because we've had to expand that superset as we've gone to like a ggplot converter, to a matplotlib converter, to a MATLAB converter. We also wrote this one for this really old school physics graphing library program called Igor Pro, which you might know if you're a quantum physicist. So yeah, it's a superset of all those graphing libraries.
Have there been any big surprises?
That's a good question. Any surprises, Jack? I don't think so, because our team was we were MATLAB experts. One of us loved Igor Pro. There were some R folks. So we all kind of brought in these different ideas of how we wanted to describe visualizations in a declarative way. Yeah.
I was about to ask a similar question, but I a little bit more on the JSON part. So you have the clients, let's say an R package. Is the R package doing that transformation before you send it to the
it is.
server? So you serialize it into JSON, and that's what you send. So someone could look at how that format looks like.
Yeah, absolutely.
And is it so? And if you make a plot, you also have data. You have I think JSON. You can hit the button that says JSON.
Yeah.
Exactly. That serialized.
Yeah, exactly.
You can maybe you can show it to us.
Yeah. So this was this graph we created in R. And this is the serialized version of this graph that we created. So just to back up again, we created this graph in R with ggplot. Then we crawled through this graph object and grabbed all the different attributes of this and then filled in a JSON structure that describes this graph.
So the JSON has already the colors and everything, or?
Yeah, exactly. So here's the X data, here's the Y data. Mode markers means it's a scatter plot. I'll zoom in a little bit here. In fact, you can just add .json. Oops, lowercase though. So X, Y, and then marker color, the size of the markers. We're looking at circles. They're bound to, there's only one X and Y axis. That's one of the traces that we were looking at. Here's the next one. There's more data, X, Y, mode markers. We can come down here. Here's how we describe a legend. There's the position of the legend, the fonts, the background colors, the border colors. This declarative representation of graphs.
How can you add attributes that are not in ggplot, for example, tooltips?
Yeah, you can, exactly. So there's a way you can just, this command ggplotly does all of that at once. So it converts the figure into JSON and then it sends that up. But you can just convert the ggplotly graph into JSON and then edit that JSON and then send it up. So people do that, for example, they'll create a scatter plot in ggplot and then they'll add text elements to each one of the scatter points and then they'll send that up to Plotly so that their scatter plot can have hover text.
Is that like a simple function call or is it involved?
Yeah, it is. It's I think it's something like gg to list. something like, yeah, but you have to pass in the plot. I think this is, yeah, so here's the description of this graph as described in R objects, so named lists for R. And then here you can change these different elements and then send that up.
Have you found a practical limitation to the number of points that can be described in this fashion?
Yeah, for scatter plots, so the question was, is there a limitation to the number of points you can plot? For scatter plots, it's limited to about 50,000 points before interactivity starts to slow down. For line plots, we do min-max decimations. That means that we don't draw all of the points, but we make sure to draw the min and the max over these regions. And in that way, we can get up to about 500,000 points. So the limitation in drawing is really two things. First is the network speed of just shipping that much data up. And that's a lot faster on sort of private servers. And then the other limitation is just drawing the SVG elements in the web browser. Yeah.
I particularly like the 3D stuff you're doing. Like, what program do you come from to feed that into Plotly, or can you just do that without coming?
Yeah, so for that, you can use any of the programming languages, but not necessarily sort of the figure converters. So ggplot, for example, doesn't have a grammar or a geom around 3D scatters. But you can just describe the 3D graph in our declarative JSON format and recreate that with something like R. So, for example...
So there's no RGL converter?
So there's no...
RGL?
No, there isn't. So there's some error with this code. But you can just pass in the declarative representation of the graph and recreate this in R. So how we describe this in R is there's a Z, and then there's a type, and then there's a title to this graph. So to your earlier point about kind of describing these graphs as JSON in a uniform way, what that means is that you can view the code that would generate this graph in any other language, because just as you can convert any of these objects to in different languages to JSON, you can go the other way too. So this is a graph we created in MATLAB, but if I add .py to the URL, here's how I'd recreate this in Python. Here's how I'd create this graph in R, or in Julia, in JSON, or back in MATLAB. So this is kind of the cool thing about describing graphs declaratively. So one of the things that we're working on this year is we're writing the next version of Matplotlib, Python's graphing library, in order to have this middle layer that describes graphs. So for our Matplotlib converter right now, we can't convert all of the graphs to Plotly just because it's not possible to crawl that object, the figure objects in Matplotlib like it is in R or in Python. So we're making that accessible to the Matplotlib figure objects. And we're going to sort of describe Matplotlib figures in sort of a similar way that we describe them in Plotly. So you can go from Matplotlib to Plotly to R, back to Matplotlib, just interchange graphs and data between all of these languages and with the cloud.
So in R is mainly ggplot, or also base R, lattice, or?
For R, we've just been focusing on ggplot converters. And then also just kind of the regular declarative syntax that we describe graphs natively.
And on ggplot, what do you think is the coverage now of the geoms?
It's about 80% right now. Yeah. And these packages that I'm talking about are all open source on our GitHub. So our package is part of our OpenSci.
Do you know out of top, so you had, what would be something that's missing in ggplot?
Yeah, geom smooth is one of them that's missing. There's also some custom text, colors of text right now that are missing.
Smooth is probably tough because you need some statistical function, and I'm not sure where you're gonna do that on the client side.
Yeah, we'll likely use that statistical function to compute the values and then send that up and draw it as an area plot. And if there's anyone here, this is kind of a random plug, but if there's anyone here who is really interested by this and would love to round out the rest of the ggplotly library, first it's open source and we love contributions, but also there's some opportunities to work as contractors and help us bring this guy to 100%.
Did you look at ggviz?
Yeah, we have.
What are your thoughts on ggviz? So obviously, it's pretty immature at this point, so but they're developing it pretty fast.
Yeah.
Hadley and Wisdom.
Yeah, it's definitely looking good so far. When we started out, we were kind of solving different problems we wanted to do more sort of interchangeability, and I think one of the cool things is going to be integrating these types of JavaScript graphing libraries into Shiny apps. And I'll show you some sort of similar examples of this. Just because with interactivity, you can do all these cool things like where if you click on a point, you can grab that data of that point and then redraw, populate the new figure with it. And same thing with hovering and zooming. These things are a lot easier to do in JavaScript than in other languages for building GUIs.
I'm just like, within an organization, what's kind of like a setup for incoming data, and then kind of having set up so we have data coming in, we want to kind of process it without having, let's say, someone always doing it themselves, and then have still the same level of interactivity. What's like your recommended setup? Do you just take it through Python, or how does that process kind of work?
Yeah, it sort of depends. Like if it's incoming data from like an API where you kind of want to refresh a graph maybe every day or something, some people will just write scripts in R or in Python and have cron jobs that query the data and then send that up to Plotly and overwrite graphs. A lot of folks in organizations use Plotly to just embed the graphs inside their like internal websites or in reports that they're sending out. And either having scripts that are generating these reports or just overwriting the graphs that are embedded in these pages. Yeah.
Those reports HTML documents that are interactive? Or?
Yeah, exactly. Yeah. Does that answer your question, or?
And then because you have the different, like the shift from R to JSON, kind of, is that that's almost like kind of an interesting feature if you're thinking about working like interdepartmentally within an organization, because like you can literally send something to someone, if they use something different, they can just essentially add the extension and get that changeover right away.
Exactly. So this is a graph that we created in R with ggplot. But if I'm working in Python and I want to download this graph, we've got commands to do that with our library. So I can call py.getFigure, drop in the URL, and this will download the representation, but then convert it into Python objects. So here's the representation of this figure. I can get the underlying data. That describes this figure. So this is a figure that we created originally with R in ggplot, sent that up to Plotly, and then downloaded that back down into Python. And then the person working in Python could then update that data, do post-analysis on it, and then maybe overwrite that original graph or create a new graph or send it to their friend who's working in MATLAB, who could then download it into MATLAB and bring it back up.
That's awesome. That's really cool.
So in business, lots of people still use Excel for visualization. Have you considered doing an export to Excel feature that actually builds a worksheet with the data and builds it using the Excel visualization stuff?
We've thought more about sort of going the other way, of taking like Excel spreadsheets and then syncing them to Plotly. So you can upload Excel spreadsheets into Plotly, create graphs off of that, and we also have an open source plugin. Let's see if I can bring it up. That allows you to make Plotly graphs from inside Excel. This isn't that mature yet, but it's something that that we're working on and getting feedback from. But you can use this plugin and then just select different columns in Excel, and then we return an image. Like, we can't, unfortunately, generate an interactive version, but it's an image with a link to the original Plotly graph.
Brother, yeah, I work in R, and it would be really nice if I build a thing in R to be able to push a button and have it turned into an Excel spreadsheet that my manager can look at.
Right.
So just, if you ever consider going in the other direction, I can imagine.
Okay. Yeah. That's really great to hear.
This as well.
Yeah, that's cool. That's a great use case. Yeah, I mean, one of the nice things too about this sort of collaboration that the web provides is that you can create this graph in R, and then look at the underlying data in a spreadsheet form, and share that. You can also upload grid-like data sets directly from these languages up into Plotly.
You have multiple dimensions and metrics that you're visualizing.
Yeah.
Does Plotly have the capability of using drop downs to actually look at those different dimensions as become
Yeah, and that's not something that we have like right out of the box, but we're writing more ways to build those types of interactivity really easily with JavaScript, and just simple examples of that. So I'll show a couple really sort of simple examples, but toggling sort of the different traces of a graph. This is just a simple drop down that I wrote with JavaScript in the browser. So this is definitely an area that we're starting to spend a lot more time on, just seeing kind of all the great stuff that's built with Shiny apps and with IPython notebooks, and hearing from people who want to build their own custom views of data sets that they're looking at over and over and over. Yeah.
For enterprises, do you suggest them to use the cloud version or more like on-premise?
We recommend the on-premise version. Yeah, just because a lot of the enterprises that we work with have really sensitive data. So things like Air Force, for example, Aerospace Corporation. Just keeping all of that data behind the firewall. Yeah. And then for other folks, or like some universities will use the online version and keep their data private, but just still on the web.
How about somebody like Sony whose data is actually public and private?
Time will tell if that model really works out for them. Any other questions? Well, we're going to be around here, and if you have any questions about the enterprise version or starting a pilot, or Rich has some comments about that.
I handle the corporate partnerships for Plotly, so I just want to add a couple things to what Chris said. The question I get a lot is, give us some corporate references. We've been selling our on-premise solution for about 5 or 6 months, but already we have several companies that are using us. And just to give you a short list of people that have actually contracted with Plotly: Google's Advanced Technology Arm, Air Force Research Lab, Air Force Academy, Aerospace Corporation, Goji Insurance. We're going to have a couple of NASCAR teams signed to us, believe it or not. VTT Finland, which is the largest technology lab in Northern Europe, Center for Quantum Devices, the list sort of goes on. That's all within 5 months. We also have about 30 corporate pilots going on, a lot of NDA side, so we've been really, really busy. So if you have any interest in doing a enterprise trial, which is no obligation, you can either email me at rich@plotly, or you can just drop your business card off with me after this meetup. And I'm so impressed with this group that I'm going to ship some limited edition Plotly t-shirts made by American Apparel. These are very high quality, very, very expensive. My marketing budget. If you want to just drop your card off with me, I'll ship them to Slaughter over here, one box. And for all those people that didn't show up, don't give away the t-shirts. And do me a favor, write your shirt size on the back of the card so I know what size. So once again, any questions about licensing, corporate partnerships, trials, you can email me or talk to me. Thanks,
Thanks so much for coming out.